your background, where batteries are right now and where they've come from, where do you see batteries headed? Where do you see as kind of like some of the, whether it be new technologies or just greater awareness, where do you see battery technology, especially for like electric vehicles or grid storage, headed?
Well, it's headed down a very rapid path, I can tell you that. Regardless of where we think we are today, I believe there's going to be major breakthroughs. Since coming back from China, I've identified at least 3 or 4 companies in the U.S. that's going to make some major breakthroughs and that will actually leapfrog some of the things that you and I talked about during Tesla Battery Day review. And I work with those companies, and those are going to happen. Some of these things are going to reduce costs dramatically. It's going to increase production capabilities. It will decrease the total amount of capital equipment that's required to build batteries. It will take less floor space, less utility costs, and a lot less environmental contamination from the manufacturing process of these sophisticated batteries. So I think that batteries are headed down a technology path that's going to be lower cost, higher production volumes at much reduced cost than where we are today. Now, you might ask the question, well, what is the gotcha? Where's the pinch point? The pinch point is going to be the raw material availability. Raw materials, many experts in the industry are worried about that because, particularly here in the United States, it takes roughly 10 to 12 years just to open a new mine. If somebody finds a new vein of, say, a lithium salt or something, it takes a long time to go through the process. Now, many countries have broken down those barriers for the mining operations. And there's some companies here in the United States that are working very aggressively in Washington, like Benchmark Minerals, to try to reduce the total time it takes to get new mines commissioned and get them up and running to address that specific issue. So I think if you ask the question, where's the bottleneck I'm sure is in the raw material side of it, because it sure isn't for the sake of manufacturing. The manufacturing side just requires a lot more capital, and we can build a lot more batteries. So that's really not the issue. But then you might start asking questions about, well, where are the other most interesting points for the consumer? Consumers like to be able to charge the car faster. They want to be able to go farther. So consequently, you have to have new technologies that allow us to charge faster. And you have to have technologies that give you higher energy density so you can go further. Now, most of the technology that we have today is easily propelling the car down the road at over 300 miles, which is pretty typical of a gasoline-powered car. And typically the price point for many of the cells from these large manufacturing companies are getting down below $100 per kilowatt hour at the cell level. In fact, some of them are much lower than that. Depends on the purchasing contract, how big it is. And then you got to build it into the battery modules or the battery pack, depending on whether you're going from cell to pack, module to pack, or cell to chassis, which is one of the new things that's going to be the wave of the future. And that's something I've been mentioning for years, that cell to chassis will be the future of electric vehicles, where the car manufacturers will build the chassis in such a way that the manufacturers can deliver the cells and be packaged right directly into the car. So I think that's really the wave of the future for where batteries are heading.
And is a big portion of that, I know obviously we even discussed this on the previous conversation we had around Tesla's Battery Day. They were talking about this, and while I think they probably got the most publicity about it, they're not the first necessarily to really be going down this path. Do you think now, is it partially just because batteries have now gone to a point where their kind of lifespan and degradation has become so predictable that this is kind of making it become more of a reality to have kind of this chassis integration? Or what's been kind of the thing that's been holding that or been preventing from that from happening?
Well, what we're finding is that these batteries are fully capable of lasting the lifetime of the vehicle. So as long as you don't have some kind of an infantile mortality of some type with either a cell or other components. And 98 or 99% or greater time, it's not the cells that cause the problem in the battery pack, it's some other component, or a fastener, a wire, or a solenoid, or a switch, or something that causes the battery pack to be returned back to the manufacturer for repair, because these things are fairly complicated. They're very sophisticated in terms of the total number of parts and the methodologies that are used in the manufacturing plants to put them together. So I was in an SAE meeting not long ago with some of the senior guys, and somebody made a comment, well, these battery systems can't be that complicated. And one of the other guys, before I could speak up on the executive management, says, you don't have a clue what you're talking about, because these battery packs are quite comparable to the sophistication of an internal combustion engine and or a transmission, or both combined. So there's a lot of technology in a battery pack that people don't see, because it's not a moving part. It's not something that's right there in your face, because it just sits there. But all the software, all the hardware, and the development effort that went into those, it's just a chunk of material sitting there in a box, but it's got enormous amount of power and energy in it.
And it's funny you kind of bring that up, because I do see, I think the tone's changed even within the last year, but there seemed to be this almost, I don't know if it's hubris or what, but a lot of the traditional automotive manufacturers were like, oh, this will be easy. We'll be able to make the transition to electric vehicles. We've built combustion engine cars for years. What's so hard about going to an electric car? Do you think it really is maybe just ignorance, or they're just believing that maybe they can just go to like an LG or some supplier who will have this kind of off-the-shelf solution for them?
I think it's a typical growth curve of understanding. I don't think it's ignorance. It's just a misperception of what it takes to do the job. It's not any different than where we've developed. Back in the 1960s and 70s, when I was a child and a young man growing up, I always heard my family talking about all the car fires. People were getting incinerated in gasoline car fires. And boy, that disappeared. Not long after the late 70s into the 80s and 90s, you never heard about car fires anymore, because the discovery of bladders inside the gasoline tank, different types of gasoline tanks, made them very safe. So you stopped hearing about these horrific accidents where people were getting incinerated in their cars, because the engineering world stepped up their game and created safe and effective systems. And it got safer and safer and safer as it went along. And now I can go back and remember some of the presentations that I saw at SAE over the years, when we integrated seat belts, where we integrated airbags, we integrated anti-lock braking systems that came out of the aerospace industry. So you can just go down a list of all the types of safety items that people have done over the years for automobiles. Now we're getting into a whole new era of autonomous vehicles. These autonomous vehicles are extraordinarily complicated, but they're also extraordinarily safe. They've got LiDAR, they've got radar, they've got early detection systems, control. Driving my wife's car on a long trip not long ago, the first time I put the thing into cruise control, I thought, this thing is following that car and it keeps slowing down, because it's measuring the distance between me and the car in front of me and the speed that I'm going, to make sure that I can stop in a safe way. And if I got too close, the car would slow itself down. So I see this is happening across the board in every car company around the world, where they're integrating some of these autonomous features, even in the kind of cars we have today that we are still required to steer.
Right. And no, I think autonomy, especially with electric vehicles, is such a clear next step for automotive space. Where do you think maybe some of the misperception you're talking about is just maybe the underestimate of like how much, like you said, software is involved, and that's kind of a new arena for a lot of these companies with the shift to electric and autonomy?
Mm-hmm. Oh, absolutely. People don't understand. There's an enormous amount of software that goes into the charge control mechanisms for battery, how to handshake with the different kinds of chargers that are out there. There's the brake blending function where the energy management controller on the car has to communicate with the battery management system. Battery management system has to provide the feedback to the car controller saying, look, I've got a full battery pack. I'm going downhill. You're going to have to use friction brakes, or you're going to have to burn off the energy a different way because the battery pack is full. Or if I'm going down the hill and I'm at a low state of charge, I want to pump every electron I can into that electron fuel tank called the battery pack system. So yes, there's a tremendous amount of software in there. Every car company and every battery manufacturer work very hard to make sure that that handshake occurs between the battery system and the car to assure that they're getting the optimum use of that. At the same time, the car manufacturers are working very hard to try to decrease the amount of energy that's being consumed in the car in all the other functions that go on. And I'll use start-stop as an example of that. That's kind of a precursor to the electric vehicle. Many of the European companies were the leaders in this, where they took the engine and shut it off every time the car would come up to a stop sign and then restart it. So they had to change the architecture on the motor and the generator configuration to be, in some cases, one and the same. So there's a lot of technology that's been developed over the last several years that's leading us down the path to a fully electrified vehicle. But my disappointment in some of the architecture is that many of the components today still use 12-volt components in the cars because that part of the industry has not stepped up to the fact that we're going to higher and higher voltages, when in fact many of those components actually work better at higher and higher voltages. So there's still a lot of work to be done in this electrification world that we're working on today.
Thanks for joining us. Be sure to visit our website, connectingthegrid.com. There you can listen to our podcasts, contact us about sponsorship, or even be a guest on Grid Connections. While you're at it, if you found value in this show, we'd appreciate a positive rating on your favorite podcast or video streaming service. Or if you'd simply tell a friend about the show, that would help us out a lot too. Thank you again, and I look forward to us learning more together soon.